All right, thank you guys for coming, and I guess I don't know in the video what we've missed with some introductions and everything like that, but I'll kind of just jump in. So there's kind of a whole stack here, and so I have Floe, this drag and drop programming environment that is kind of going to be used for like machine config and a few different. You can do a little bit of programming in there, and you can also do a little bit of programming and kind of machine config. So I just created a new canvas here, and we can kind of just make a little program quickly here. And so we can drag elements out here. So these are some slider elements that can show up in a GUI. And keep in mind that everything is like event-based. So anytime anything happens on this slider here, anytime anything happens on this first slider, it will send out a message to the second slider, and this one will pick it up and go to whatever value that it has been passed. So we can go ahead and we can save this, and let's go ahead and fire it up. So again, we are running Python in the browser here, and so we've got Python under the hood, and you can see here that like this is pretty just like simple stupid demo, somewhat contrived, but you can see here now that we have two sliders. You can move around one slider. When you moved around the other slider, you can see here, let's and again, it's Python underneath the hood, so you can type in anything here, and it's just a Python terminal. And also all these elements also exist, so you can see here if I type this in, we actually like get that object, and you can also use this to send it a message if you want. So you can go ahead and send that one to 0, and like again, you have now called it, and so you can go ahead and create programs by this. So let's go ahead and open up another program that I have here. And at any time, I'm curious, Bart, if you want to like chime in and tell me about what you think about any of these. Where is my drink maker? So, well, I guess I'll start with the robot that we have here and kind of go over that a little bit. And let's open up this program. So the robot arm that I have on the table here is running this program. So you can see down here we have our gerbil parameter over here and a bunch of supporting parameters, the kinematics and whatnot that will help make this guy go. We've got the encoders here, and again, these are I2C, so it's running MicroPython under the hood. And you can see here also that we have this pen object, which is just a PWM, so that's a servo for the little pen tool head that we have on here. Also another slider, come back, and we got a checkbox that will go to a function, and this guy's basically just going to like return our 0 or a 1. That's going to go to the slider to go ahead and change that. So if we go ahead and look at what we have here, this is actually, there's a WebSocket connection from this web page to the robot, and let's go ahead and close some of this stuff that we don't need at the moment. And you can see here, just like how we did the slider, you can have some elements here, and you can see that like when I hit this pen checkbox here, that we're actually moving the pen up and down. We have this, again, this is just a slider here, so you can see when I move this guy a little bit, we're also manipulating the pen tool head itself. This should also be up here. So anybody who's kind of familiar with working with Python and any of these, you'll know that you'll want to set the duty. And you can see here that like when I type pen.duty, what did I do? So like the duty for this PWM object, if we go back to our program here real quick, like in fact is this slider object. So if we go ahead and we can call that just like anything else. And you can see that like when we do this, we move the pen up and down. There's also a whole like interface to interface with gerbil like you would assume with a normal CNC. So again, this is what I was talking about earlier. You can see that like I was talking to Bart right here. When I do this, like it's jogging the machine underneath where the encoders are set. So we can go ahead and just like move this guy home if we wanted. So right now the machine's just moving to 0, 0. And I'm curious where you like 0, 0 on your machines when you do them. Do you do it, Bart, just like how you'd have it with your unit circle, where it's like 90 to the side? All right.
Generally, yeah, but you know which way you're facing it or whatever, it doesn't really matter. But yeah, are you working in radians or degrees, or what are you doing?
Degrees.
Okay. Yeah, unit circle will still be same 0.
Yeah, I guess I do like an implicit transform, so that like you're actually at 90 on theta is offset. So again,
yeah, if you're using like a servo or something, you might be stuck with what it thinks it's 0. You know, more likely. You know, like it's got, you know.
Yeah, well, I mean, I guess that would all could be handled underneath your kinematics. So again, there's like a little terminal in here. What's something that I can type in here?
So you have optos on your axes.
I'm sorry?
You have optos on your axes.
Optos.
Opto couplers, opto isolators, opto sensors.
They're encoders.
There's
magnetic encoders.
Oh, magnetic encoders. Okay.
Yeah.
So that's why you said they're absolute.
That's correct. Well, not all magnetic encoders are absolute, but like these particular ones, you can talk to them over I²C. And
cool. Very nice.
So again, you got a bunch of machine-like interfaces that you have here with like a normal what you'd expect with the CNC, but then you can also add on some kind of like peripherals by creating some boxes over here for like a pen tool head, or one of the other things that I'm working on is pick and place machine for assembling circuit boards. But I guess since we have Bart here, I'm kind of interested in what he's thinking about this robot arm, or this bartending robot that we have. So I made a bartending robot, and I guess right here we have a scale. So off on another board we had a scale that would weigh the drink, so that as we were pouring some of the fluid in there, the fluid being alcoholic beverages, we can go until it reaches some level. And again, because we're running in this environment, we can actually like pull up the program that runs on the robot itself. Again, like, you know, we have this particular program here, which is running on that robot arm there, but you can go ahead also and just like run this in your browser. So if you wanted to prove out some of your code or do whatnot, you can just run it in your browser and run through it before you actually put it onto your robot. So again, we have a bunch of drink taps where you can start or stop pouring in this particular bartending robot. These make drink buttons will start up routines, which will actually go through and start making a drink of some kind. These are these buttons here. And when you press one of these buttons, effectively you're going to end up into this little module here. So, you know, instead of G-code, you're programming things in Python. So we've created a bunch of objects here, which are our grippers, our taps, you know, our drink level and whatnot. And so we can send messages to a bunch of these objects based on whatever it is that we want to do. So when we start this, pretty much the pieces that we're interested in is like get cup, right? So what we're going to do, we want to make a drink, we got to get a cup. And so we have a little function here that's going to go and just get a cup. And one thing that I didn't have implemented when I actually made this program that I do now, there's now implicit kinematics. So if you have T or P in here, it will actually set the joint angles. But if you do X or Y, then it will actually go to whatever coordinate set that you have. So I guess keep in mind when you're looking at this that this has changed. But so we're going to move over, close the gripper, pick it up, and move it over to where we would actually start pouring. And then in this particular example here, we get from this to this wait until. And so, again, keep in mind that everything is event-based. So anytime that something happens on this scale, it is going to be sending out a message. And so when we reach this part in our code, basically we are going to be making a little subscription to this thing called drink level. And every time that drink level sends out a message, this little lambda here is going to catch it, and we're going to evaluate here until this evaluation returns true.
Do you have a timeout in case something goes wrong?
No, that's an interesting.
Nothing goes wrong. Nothing ever goes wrong.
Well, like you run out of bourbon, your little peristaltic pump is going,
Mm-hmm.
you never reach your weight.
That is an interesting.
And then the until sets a flag of generating an error downstream somewhere. Sitting.
That is an interesting keywords that you can put in there for timeouts.
Yeah, I mean, it has not, G-code has a wait function, but there's always an until because things always go wrong.
What are you waiting for in G-code?
Or
Or what kind of things return? Like a spindle on or something like that?
Yeah, there's a lot of things you could wait for. Like an operator, to tighten clamp and push button. Or something.
Well, that's M1. That's a little different, but I guess that is sort of a wait.
I mean, it's not something that would make sense for you to use because you can control things at a higher level.
Yeah.
But
all right, cool. Thanks. But in G-code, there is no kind of way to implicitly wait for some kind of random event. Or is there in FluidNC? Some
there's a wait for event. It's usually like a control input.
Gotcha. Okay.
It's not like getting somewhere. That's naturally just waits until.
Yeah.
But yeah, you can wait on a control input.
So anyways, we've opened up the tap. We're waiting until it's full. We will wait until it's full, close the tap, and then more of this serve is just some more move commands down here that are going to serve the drink to where it comes from. So you'll see yield with this keyword here. Everything yields to a generator, or this function is a generator. So you're always having to yield every command to your. Why can't I think of the name that I came up with it? I'm sorry?
Event loop?
Not quite an event loop. Your execution manager or something like that. None of this kind of events ends up in your event loop per se, because everything is kind of anything that you're waiting for is kind of handled somewhere else, whether it be actually waiting for fluid NC to finish a move and get back to say that, like, okay, the robot has actually reached the position that you told it to get to, and or some of these wait commands or sleep commands. I kind of think of this sort of like execution method as what I'm calling an orchestration, because you're kind of like more like a conductor, working with a whole bunch of different objects and waiting and controlling, while kind of more on the kind of canvas side here. These are like compositions where you're actually kind of like wiring things up to sort of, if this then that is sort of like words, but I don't necessarily like using those because it's not necessarily what's going on here. But again, these are more like compositions. Let's go ahead and what's something that I want to also show. So you have some kind of drawing or something like that, and this is an example that came from Inkscape. So I drew a picture in Inkscape. It pooped out some G-code, and then this G-code, I can go ahead and run this. And you can see here that we have G-code just like you would normally imagine. And we are going to do some transforms and some translations on it, and then also put it to code that the execution manager over in the Python side will wish to handle. So what you're going to run is something called like JSON lines. So it's basically just every line is a chunk of JSON, and as it comes in, you will have I'm calling this entire thing an order. Does anybody have any interest on that name? I'm looking for a name for a line. But basically, every order has a command. So, at some level, you can kind of imagine that these commands are just some kind of like RPC, because it is beneficial to be able to serialize all this in case you are kind of having some controller somewhere that's going to tell something somewhere else to go ahead and run something. And this having things run on other devices is kind of what this whole Floe program is all about, which I guess I will get to in a second. But you can see here that we have run this G-code here, and we are exporting this out. And does this one also? Does not. Let's go ahead, and I'm going to copy all this. Let's open it in one of the ones that does some SCARA transforms. So again, the same kinematics processor that we have for the robot, we kind of just dropped in here, and we can pre-compile some code if we want to. So you can either like drop G-code in and kind of feed it back through and kind of have the robot run straight G-code, and or you can pre-process some of this and also just kind of send in this JSON lines as some pre-compiled code. So let's go ahead and run this guy real quick. And also, keep in mind that the 3D viewer that we have basically shows up by the very nature of the fact that we have some 3D viewer objects in here that call for it, and so then it's automatically rendered on here because of the fact that like something called on for it to be rendered. So let's go ahead. We're just going to drop in the G-code that we had before, and we have a few different objects here. Again, everything is like pretty raw. I want to make some kind of higher level objects that will handle some of this. But for right now, putting together the primitives, if you will, is more beneficial for as I'm debugging things. But you can go ahead and kind of rotate or offset any of these. And let's go ahead and give these some different colors as well. and then we'll just submit our original again. And you can see here, let's change the color of this guy. Whoops. Anyways, so we have the original here, and you can see that we have translated and rotated. So one of the fun things about robots is the fact that there are no straight lines. So with a regular Cartesian machine, you're typically setting up something in X, and it's always X, but with robot arms and polar things, there are no actual straight lines. So you have to also tell it where in space and then what kind of rotational angle you want. And it is also kind of neat that even though it is polar, sorry, I'm not very good at doing this on my trackpad, that you can see that like this is actually the SCARA code. And so basically what we're doing is we're taking the original code and chopping it up into little bits. And so any of the straight lines are chopped up and converted into smaller straight lines, which approximate some arcs. But the first time that I did this, I thought it was pretty neat that you could actually see what was going to be drawn, even though it's not in Cartesian space.
Polar dumped into Cartesian.
Yeah, effectively. And again, I guess I'm sorry.
I don't know how the units work, but
well, I mean, 1 degree would be 1 unit. So effectively here, if I can zoom out a little bit here, you can see that right now it's in right-handed mode. So theta is mapped to, or I'm sorry, phi is mapped to y. And so if you went and actually changed it to left-handed, we can go and just like compile this entire thing again. You can see here, let's give this guy a different color so that you can see that like now it has dropped into negative y because of the fact that phi will be negative because we're actually in left-handed mode then. And it's also reversed. I have left-handed family members, so you have to love them even if it is backwards. I forget what I was going to say. Okay, so we have a bunch of different kind of tool chains that you can go through to, run your robot, configure your robot, and tool chains to develop code for it. There are some other ones for like pick and place and some other operations that I'm doing, but I guess I don't know how we're doing on time and how much time you guys want to give me.
You got until the building closes.
When the room's empty, you should probably stop by.
Sounds good.
Or not, whatever.
All right, this is good.
Feel free to ask any questions along here as well, if you have any.
I have a question.
Sure.
How did you choose the GUI building libraries that you used? like the one
This is all written from scratch.
I mean the like previous screen.
This one here.
Yeah.
So this is based off of another person's project called Draw2D.
Okay.
And so basically the way to craft some of these boxes and lines was already there, and then I took it and kind of mashed it into what you see here.
No,
this was
that's what you're supposed to do. I was just wondering what the because building the thing to make all the little IOs work and everything is probably extremely tedious and probably took a while. And if you can leverage that, then rock and roll.
Yeah, so the guy who originally created this as some kind of like electrical engineering tool. So I kind of took that, and I guess let's go ahead here.
What's it called?
Draw 2D. So we have a bunch of these here. I need to have this like in some kind of order. Let's just look for the slider. So you were asking the boxes and lines.
Yeah.
So let's go ahead and just put this over to the side again. So we have, what did I, was it the first one? Well, anyway, so we have a slider.
Right.
And so then this is functionally what is going to create a slider object. So we have some markdown at the top here, and this is going to be a little bit of text on like, do I have a slider here?
You attach an object, an action to an object. Is that?
No, this is kind of like how are we going to build whatever this thing is. So like, as each one of these boxes contains various different things. So there's a description or like documentation on what is this thing, how does it work, and whatnot. We have this JSON constructor here, and so this one is going to tell you how am I going to make this boxes and lines. What are the inputs? Also, one of the things that probably glossed over is when you drag these around, they're typed. So you can see that like not all of you can't link these to some different things. The wrong thing, yeah. So whatever kind of like types you have over here, and I know that I have any for a bunch of these because I'm working on having multiple types. I haven't quite implemented that yet. So you can do some wrong things, but it is in the works that you can kind of only hook things to things that are supposed to be hooked with each other. But anyways, there's a bit of JSON here, which is like, how do I construct this? What are some of the things that are going to be some constants inside of here, like this invert or output float, and just some other informations.
You can't rewire this while it's running, can you? Like move the IO lines around on the objects.
You'd save it and then like
And restart it.
Yeah.
Okay.
Yeah, so it's not like something that's live.
I've never seen one that was. Yeah.
Yeah, it's pretty close. So I guess just moving on here, and I will get to that in 1 second. But then we have some Python, and again, like when you're running things in the browser like this, it's kind of weird to think about the fact that like your server is in the browser also. But technically, this Python code, whether it's in the browser or on the robot, this is the code that's actually going to be running kind of on the server side to make this slider object be whatever it's going to be. And then down here, we have a bit of HTML, like how am I going to build this slider on the web page, and then a bit of JavaScript, which is going to handle the building of the HTML elements, and how am I going to send and receive different messages based on what is happening.
What is where you had the 3D field and you were like spinning that around? What kind of object element, whatever that you call this thing, produced that? Is it just another one of these, but with like some 3D calls in it? Or is
yeah. I can open that one if you like instead.
What's rendering the 3D thing?
You're about to see.
You're actually not about to see, but it is 3JS, which is a 3D rendering JavaScript library.
So it's running in a browser?
Yes.
Okay.
Yeah, so effectively here, so again, this is the 3D viewer where you're going to put in our JSON lines, our list of orders, that is the code that like a robot would run, and how do we want to build this thing? Do I want to have one on the other screen here? I don't know if this really matters. Yeah, there's not a whole lot going on here. So we have, again, there's not really much code that makes a lot of these go. So, we just have a spot to put in some code. When we get code, we'll just send our code as a event when something happens. We have some HTML, which is going to just be the, what you see here. It's just going to build this editor, and then some JavaScript down here, and where do we have it? Yeah, basically, I have this 3D viewer that we're just going to dump in our code and tell it to render. I guess that's not very exciting. I can open up some of the code, but again, it's there's really nothing kind of exciting happening under the hood anywhere here. But when you mix them all together, I hope it makes some magic happen. So Ed was asking about the code and if it, you could do something live, and basically when you hit save, we are going to compile it here. So let's go ahead and make this bigger. When you save it, you're actually going to dump out just some Python code that looks like this, and you can see here that all the objects, the Python objects that go to construct this program are all in here, and then we're basically just making a bunch of Python objects that are whatever this program is. And again, none of this is very exciting, but kind of the part that would make this crappy to program, just if you're writing Python natively, is kind of this kind of code here, where we just have a net list. Right? Net lists made out of words is not fun. I guess somebody who does electrical engineering, it's I would rather look at a schematic than a net list. So, effectively, because everything is event-based, we, are kind of just wiring things up while each parameter or objects themselves. Some custom code. Yeah, some more Python. I guess so. Basically, the canvas itself, this kind of thing here, is this kind of just JSON garbage. It's this type of thing. Its name, where is it? And all of that is basically this garbage, and then we have a transposer that takes this and effectively dumps out everything else that you see on the screen here, most notably this.
So is that drawing robot you're showing, is that this?
I mean, we can, that'd be this one here, and
you're generating Python code and then MicroPython's running it, right?
that's correct. Yeah, what are you trying to look at, Bart?
This is the code for this robot?
Yes, exactly.
So in this, is the servo controlled by G code, or is it at a higher level in here?
It's at the higher level up here. Okay. So the actual pin that is running the PWM signal itself is actually the host, okay, running MicroPython.
So you're not using G code for Z moves, that's interesting.
Yeah, I mean, effectively it could be.
So where is the verbal interface block?
That is this guy here.
Okay. Have you ever used multiple verbal interface blocks for a machine?
I don't know what that would even mean.
Two separate verbal controllers.
Oh.
Like the robots playing tennis,
So, yeah, I will get to there in a little bit. Okay. We'll get there. No, but yes. So, having two of these objects on a single canvas here would be a little weird. I don't know. I struggled to come up with a reason that you would have two, even though you could have two if you wanted.
Well, if you have a robot arm placing something on a pallet in a CNC machine.
Yes. Yeah, I mean, I guess I will get to that in a moment. Why are you so small? Oh. I guess, especially since Bart is here. Where's my list parameters one? I should start closing some of these tabs, yeah. So the Scar one is a child of this native gerbil object. But this is definitely probably one of the most complex, or is absolutely the most complex object that we have right now. So this guy is a buffer that I can use, because you have to remember when you are running a CNC machine, you don't want to like move and then stop and then move and stop. So you actually have to like send commands. If you're moving in a straight line and you have it chopped up into a bunch of segments, you want to like send a bunch of them so that the controller can know I can say up to speed as I'm like crashing through these waypoints. So effectively
You want to
here,
use the motion planning of your controller.
yeah, the wonderful stuff that Bart has made, like, you know, you want to use it. Yeah, so effectively, you know, you want to like, and this is another one of these things that's like unusual for the way that most programmers think about programs. Like, you have to think about time and kind of where you are. So kind of when you're programming some stuff, you're actually you're running in the future of where things are actually happening.
Equals WTF.
Where did I? Oh, yeah. Yeah, so this object here wants a little function. So a fucked up thing. We create our objects, but any of these connections, like if any of these objects here have another object that they want to have, like the PWM object wants to have that slider, but when the PWM object gets created, the slider might not exist yet. So that was just a little placeholder that something can go and it can be happy, because Python oftentimes doesn't give a shit about something as long as, if it expects something that is a callable, as long as it has a callable, it will be happy. Duck typed.
So
would be the-
TBD, not WTF.
Actually, it is changed. It is not. It is now _null in the branch that I'm working on, my dev branch. So that has been changed, but not currently. So thank you for pointing that out. Yeah. So fundamentally, we have that, and then basically some different kind of move commands. We have rapid and linear, but keep in mind also that, like, you know, especially with robot arms, there's kind of different ways to get from one point to another. Even with old CNC machines, a rapid move you can't guarantee is going to be a straight line. Some of the old ones, they'll just like kind of go off at a 45-degree angle until one axis has met its waypoint, or whatever you want to call.
G1 is
Target
actually
value.
called coordinated move or something.
Yes, yeah. But especially with robot arms now, you know, are we moving across, or are we wanting to move in a straight line, or there's some other ones that I want to implement later, like ones that think about gravity would be interesting. I don't know if there's a whole lot more inside of here that is interesting to anyone other than maybe Bart. And again, all this is online, so Bart or anybody else who wants to take a look at it eventually, I really would be interested to hear what you think.
So this speaks to the robot via Wi-Fi, or is it serially hooked up?
So there are two ESP32 chips on the robot itself. One of them is running Gerbil or Fluid NC, and the other one is running MicroPython and the code that's compiled from Floe that you see here.
And you talk to the Python one via.
I talked to Python over Wi-Fi, and then that speaks to Gerbil over Serial. And Serial is kind of the only game in town for, I mean, other than, like, that's the only place that you have that you can send stuff in on your. No, I mean, board to board, and we're locked at 115.
Make a mess with that many,
What's up?
Make a mess with that many Wi-Fi clients of those.
Yeah.
Would you want it to go faster if it could?
Well, I mean, it would be kind of nice to change the baud rate to like 1 megahertz or something like that, but like,
It can do
again,
that. It's legal.
I mean,
It's running at a megahertz TTL serial.
but not like through the front door. Like, you can't. Does that send G code?
Yeah, it's total Dribble protocol.
It's
Oh,
just
really?
it's the UARTs max out is what you're concerned about.
They
Yeah.
they die of electrical noise. The chip will go as fast as you want. So you go until it doesn't work anymore.
Well, you also want to be at a legal baud rate, and 1 megahertz is a legal baud rate. It's like the 9600, 48, whatever, 4800. It's in that group of standard.
Yeah, the ESP32 is using its own optimizers and stuff. You can do just about anything.
Yeah. Well, I guess what I'm getting at is just like through the front door or whatever on
Yeah.
your Gerbil controller, like it's locked at 115K, right?
No, it's not. You can change it.
Oh, I thought you. Is this new?
No, it's with the channels. You can set the baud rate whatever you want. So things like Fluid MC and web UI and stuff like that.
Uh-huh.
Also, the debugging of like backtrace
Mhm.
is all done at 115 by default.
Yes.
And when the chip starts up and stuff, so might as well just stick with that.
Yeah.
It used to be 9600.
I mean, again, with a buffer, and it's got a pretty big buffer.
Yeah.
If you're thoughtful about the way that you're dumping your bytes in,
Yeah.
you
The-
shouldn't
yeah,
overflow.
E32 has 3 UARTs. We can allow any of them as a input channel to control the system. So you can have a sender on the primary one, and this is just a different kind of sender. And any baud rate you want.
I wish ESP32s came with more pins.
That's just
What is it?
IO expander.
Oh, no. I mean, like,
Oh.
the ESP32 itself. I have two ESP32s. They're...
S3 has a few extra,
Mhm.
but that's a real can of worms. It doesn't support the I2S very well.
Is that right? Okay.
Speaking of ESP32 S3s with few GPIOs, I used all of the ones that were available, and that's how many pins you get.
Oh,
Yeah.
cool.
This uses the S3 in here.
Nice.
Yeah. How many you get? About 8 more or so? Not many. Coming in. Original.
This fits into a 40p div.
Yeah.
I don't mind.
Yeah, well, I'm running out of pins more on the MicroPython side than I am on the Fluid NC side. Because you guys also have your shift register output. So I guess another question here was about I/O expanders and or having two individual
Seems like it would work, right?
gerbil. Yeah, I mean, like technically,
Another UART.
you'd need another UART. Yeah, you can see here that like there is this UART object,
Yeah.
and so it's just set up a couple pins, a baud rate, and then some other just like stuff on how it will work, which
Right.
bus you want to use. I'm sorry. Same thing with the I squared C. So any of these buses are kind of just.
So this is like expandable to whatever you can think of that you can make to attach to it.
Yeah, pretty much. So
Like in terms of interfaces, or like if you have a new sensor that picks a different interface or something, you can make that and attach it.
yeah, so again, we got the encoders here. I've got another one that's a QR reader. So this guy speaks over UART, I think. We've got the scale, so it's read
Like
some of
if
your
you had
load
to go in and
cells.
Put a pH meter or something on it, you could do that.
Yep, exactly. So as long as somebody created all four of those, some Python code, how do we draw the box itself, and kind of like that, then yeah, you can have unlimited. We've got the RFID. So yeah, all different kinds of hardware, NeoPixels, and then just the standard kind of what you would expect on any kind of microcontroller, the PWM or different communication buses, SD card.
I want to say I really like the presentation of the thing, and I like the colors and the proportions of the boxes, and the font that you used is easy to read, and the green on the gray is easy to see. It's a nice look. Yeah, the yellow highlight. It's a nice look.
Thank you. So we have this particular canvas here, which would be the robot, and then kind of what we were alluding to before was like, can we have two robots working together, and or kind of, we go and we want to network together a bunch of different devices to accomplish some kind of goal. So again, this was the robot bartender that we saw before, which is actually the robot that's over in the middle of the table over there. So that one, the encoders themselves are not actually on the same circuit board as the and how about I just open that real quick here.
What's the target market?
I mean, that's a decent question. It's kind of any kind of robotics. So, like, Bart was saying machine tending or any of this. I'm working on doing pick and place. So, assembling circuit boards or, a lot of this is just generic. You want to make a bartending robot or any of these things, At some level, like, what is it that you're trying... I'm doing all this, like, what is it that, like, I'm trying to do here? And...
You're describing the application, which is not necessarily the target market.
Correct, yeah. I mean, like, really what people want is they want to push a button and they get their cup of coffee or whatever. Make me a cheeseburger button.
Well, I mean, the difference in the question is, what does this do versus what does this do for me? And the coffee is one answer, and the instance of motion control or application of motion control is the other answer.
Yeah. So, I mean, fundamentally, kind of what a lot of this is about is to get things down to the point where you can have something like this. Why are we frozen?
I guess another way of looking at Peter's question is, who do you visualize using this? Like, what a person in what line of business or hobby? How would you characterize the user?
Well, like the bartender robot. What does the bartender see?
No, not that. Not the end application. The user of this. The user.
Right.
Who is the user of this thing that you've made here?
Well, I mean, the person who wants to make a robot bartender or create some automated factory line or any of these other.
This looks like it could be a rapid prototyping tool for some kind of serious industrial process.
For warehousing.
But do you see it as a rapid prototyping tool or
well, I mean, it's a building tool. Like, what is?
Why
Why is it limited to prototype?
Yeah, that's kind of what I was getting at. Like, you know, you make it, you can move fast, but then as soon as it does, I mean, like, what here like stops it from just being something that's in production?
So if you make a bartender robot, how do you deploy these? Is there a screen that they use that is totally obscured from all this stuff?
Well, I mean,
It's read only, and it gives them feedback like.
well, I mean, that's
Drawing
like, you know,
20%
this web GUI, right? Like whatever you wish to throw up onto this GUI, and or whatever is like where the person actually like interacts with this. So like you don't actually, unless you're programming, you don't need to mess with any of this underlying. Like you're just like wiring stuff up and creating objects and like.
Where do you put in gin and tonic?
That would be one of these make drink buttons, right? So, you know,
This is all what's behind the web GUI.
Show me gin and
This is all
tonic.
behind that. The gin and tonic would be a picture of a gin and tonic and a field
Or
of
the word
pictures of drinks.
Gin and tonic.
No, it's a picture of a gin and tonic on a page
That
of
could be
happy
too.
people having gin and tonics. And you
Might not do pictures. I'll bet it can do words.
no, this sits
I mean,
behind
it
the
will
web
do
page.
pictures eventually, right? Like,
This sits behind.
great,
a
there's
web
your
page.
gin and tonic.
You can activate these things from a web interface, right? So,
Not if he hasn't made that yet.
well,
I mean, yeah. Thank you, Carl. You know, gin and tonic.
It's-
You have your drink recipes. Where would this be? Well, I mean, I guess fundamentally that's simple right here because each one of these it was pre-mixed and like, you know, it's just basically opening tap one, which in this case would be gin and tonic. If you could create some more elaborate recipes here for your drink recipes. I want tonic and gin or Coke and Bacardi, you know, like, and then when you make your functions down here, you know, you can read from that recipe and fulfill whatever kind of goals you're going for, which is again why this is nice where it's Python, because Python is well suited to that sort of task where we're, you know,
where's the Python running actually?
on the robot.
On the microcontroller running MicroPython.
Yes.
So how does this window get open with that terminal? This is like a terminal window then.
Well, this is a terminal window. So like this is this program here, right? Like I just spun this up in the browser.
Yeah.
So like we have make drink 2,
This
right?
is
Like
Python generating Python.
yeah.
So
you have web
he's working with
assembly.
one Python and
You're-
shipping Python over there.
Well, there was a screen full of Python there just a second ago, and
So okay.
I was wondering
I
where
get,
that.
we'll
that
bridge this
Python-
gap here real quick.
where's
So
that Python
we've got
running?
some that we compiled what you just saw over there. This is our drinks. It's got all our recipes, blah blah, all of that. I want to now put this onto the robot. You can click this download zip button. We are going to get a zip file, and then inside of here are all of the Python modules that are required to make this thing go, along with some of the superset, and then this config.py
Okay, I'm
right here.
sorry, I'm being dense. I'm really sorry, but I'm not keeping up with you. These files, these Python files on the right, where are they physically?
They're within the zip file.
Where does yes? Where is that in the robot? In the-
Yeah, that's in the robot.
That's in the robot. So that was a terminal connection to the robot.
Uh,
A
Cool.
Pi serial, whatever, a connection to this serial port on the.
no, it's just connected over Wi-Fi.
'Cause there's
Well,
two
all right,
boards.
Wi-Fi
yeah.
then.
Are you using MicroPython REPL?
Hang on.
No.
MicroPython is running a web server, right?
Yeah, MicroPython's running a web server. We're opening the web server, and the web page is actually created by virtue of the objects that we have dropped onto our canvas. And then the way that they're wired up is also on there. And then like the files, so like these are the files that are in the file system. on the robot.
Okay. And
So if you opened any of these, you can see that like this just like is the Python files that is.
Okay, I've touched MicroPython, so I do understand how this would look, like that being a file manager. But the previous screen, the screen that had the Python in it that has the, was this it?
Yeah.
Okay, can you scroll up so I can identify the thing as being what I thought it was? Where does this live exactly?
This. Well, I mean, this is like the exchange format between the program and the robot.
Hold on.
So like this is running on here, right? Like this is this.
An assumption I made a long time ago was something other than a browser was running on your laptop. And that's not really the case, right? Like everything, all of this.
Well, you can run Python in WASM actually, and that's what I was wondering if this was. I didn't want to ask.
That is what.
I didn't want to ask.
I mean, so when I'm just running an example in the browser, so like here we are, here is the drink maker robot, right? But like we have no bartender robot here, and yet I'm running this. This is running MicroPython WASM in the browser.
That's what I was wondering.
That's the code there, but
that-
my WebSocket connection over to there, the Python that's running in WASM
This is the
in
first
this
time
example.
I've ever seen this. This is the first time I've ever seen WASM Python. This is amazing. This is a moment. I'm having a moment. Thank you.
Glad I could do that for you.
All right.
You asked about user interface and GUI and buttons, right?
No, what I was
What
trying to
is the
figure out, what I was
body
trying to
of-
ask without putting too fine a point on it, because there are feelings about this out
I'm
there.
talking to Bart, who asked a question.
Okay.
Well, I would,
Because
I think I got my answer,
I think good.
but I have more questions.
Yeah, go ahead.
So we're looking at a browser window coming from a web server somewhere.
Hang on, the web server is 3 feet from your head.
Okay.
It
Or it could be
No.
Evezor.com.
Okay. All right. Let's unpack this then. I guess we'll like start from zero, right? Like there is a server in the cloud called flow.evezor.com. When I go to this particular URL, we are going to, in the back end, be making requests for the web page, like the superstructure that is this web page, and then it is going to be populated. We're also going to have a bunch of requests here. I guess let's, is it, I can't see, 12. So, let's just like refresh this, right? Like, why did this not, did I do some, oh. We'll do that one more time.
What portion of this is cloud-based and will not run? What portion of this will not run without the cloud connection?
I mean, it depends on what you're doing. So again, let's like take this particular example here. We go to this page. We want this particular canvas to be rendered in our browser here.
Okay.
We get the web page, which has none of these elements on it, but we do get a little bit of code on here that says, I want all of these dependencies here.
Okay.
And so it's going to go and request all these, which is what you see over here. So we're effectively, you can kind of call this like pip in a way, right? It's like some kind of like package manager-y thing to where like, I need all of this Python and like, we're going to make a request for all of these objects
Can
here.
you host all of this locally? Some people don't like the cloud, or some people won't have access to it,
I don't
or
know
some
if it'll
people are
fit.
scared that it might go down.
Would all those Python programs fit?
I can't see the rest
No,
of
I
the
don't
domain, but that looks like a cloud source.
That's what he was saying.
It's just the flow.evezor.com.
Okay.
So
Not
it's just,
everything is running on the local robots.
again,
No, he
this
said the first thing that-
this is running in WASM in the browser, right? Like we're just gonna like
I'm trying to figure out where the files came from.
The cloud.
the cloud.
Okay.
Now, technically, All right, we want to do the robot one instead.
I thought
Fine.
you hacked everything.
We've got our robot here, right? Like the robot already has all of these Python files. So now we come to this web page and it's like, okay, web page, I want to, here we can, what is this? Is this, I can't remember what it is. So we have this animation, and I think, is this called GUI? So when on load here, like it's going to go through all of these objects that have been created here and say, hey, do you have anything you want me to toss on the GUI? We're going to get a blob here that we're going to toss to the constructor on the web page side. The web page side has a bunch of the Python JavaScript, right? Like we have our 4 elements here. Which one do I want to open?
Like, what is your Vezzer web server doing that the MicroPython web server couldn't do?
Nothing.
So
On
everything
this side,
could be on the MicroPython robot.
yes.
So why isn't it? Is it just convenience for you right now?
Convenience for me right
It's
now.
an easy
I can
mechanism.
change my files, and then when I hit refresh, boom. And also, ESP32s kind of suck at serving large files, and lots of them. So like,
That's why I said when it all fit. Okay, thank you.
Yeah,
Makes
yeah.
more sense now.
so while I'm running this locally right now, you still can run it. I just haven't gotten SSL kind of fully up to snuff to be able to do it somewhere that's not in my house. So like, currently,
You're just using a local open SSL certificate on.
yeah.
Okay.
And basically, all this is doing is basically just serving the JavaScript stuff, which is just, oops.
Oh.
We have the slider. So when you are making the web page, it's like, I need this JavaScript somehow, and so then that is being requested on behalf of the robot to construct the web page. Now, like, could you serve this JavaScript file from the robot? Yes, absolutely.
Right?
I mean, not currently, and especially under development, because I can change things faster just on the computer and serve things faster by not doing that.
In my experience, you don't get this performance at all out of a ESP32 website.
No, the performance kind of sucks.
Yeah.
Well,
Yeah.
I mean, 6 months ago, I didn't even believe you could run a web server on these things. So
Yeah,
it
that's a
took
fair
me
point.
at least 20 minutes to actually believe what he was saying was true.
ESP32's been around for a long time.
You can run the ESP8266 has a web server
Yeah.
built into it.
It's been doing that for 8 years or something.
Yeah.
It's been around.
The later versions of the ESP32 only have enough power to run a web server. They can also stream media while running the web server and all this other fun stuff.
Yeah, it's crazy talk.
So I have a little project where it just makes an SSID, connect to it, and then you pull it up in a web browser. And it's basically a video scaler.
Yeah, see, I'm still in like 2014.
Good times.
There's storage issues too.
Put it this way, it's like, you can't
Oh,
compare
yeah.
ESP32 to like an Arduino.
Like at some
There's
point,
also running the SQL database back in server. I'm
What?
kidding.
Actually, that was a question I was going to ask about the drink robot.
TinyDB.
Mhm.
Since the recipes are basically all JSON,
Mhm.
could the web server make a call to like a MongoDB database that feeds the JSON?
Oh, for sure.
For the drink, for a specific drink recipe.
Yeah, like I have a
a
request object here.
It's net-based.
And
client
let's
server.
see,
Okay, just
right, like
I want to make sure there was no protocol issues because it's JSON. Why not use
just some
MongoDB?
other stupid thing that like I've made. My old man is a Santa, and he wants to, have some choose your own adventure Santa. Or yeah, I guess we're getting off topic.
Also, to be clear,
My fault.
It's all good.
I don't think the browser can talk to a MongoDB database, if that was the question.
Oh, that is also probably correct.
But it could probably do a get.
Well,
Well, yeah,
make a
well,
call to
I mean-
MongoDB to
so
pull in a
I've
specific
gone down this
recipe,
pipe
like SQL
for
inject.
MQTT, and what I learned is browsers can only talk HTTP in and out. So, if your whatever, hey you guys, hush. If whatever the hell server you have talks HTTP, which kind of makes it a web server, well then sure, your web browser can talk to your web server.
I'm thinking like SQL injecting a URL, and that would pull the JSON in.
Well, again, assuming that what you're making the request to talks HTTP.
Okay.
Yeah, you can't have UDP from the
Basically,
browser.
Anything you want to talk to
And or-
HTTP bridge that
Yeah.
converts it to whatever the protocol is, the thing that it wants to talk to.
I mean, fundamentally, can you make a request? Yes, absolutely.
Okay, thank you.
So yeah, I guess when this is running, the web page itself, the JavaScript that creates all of this jazz could come from the ESP32. It is currently not. But the Python files themselves would like be loaded on there when we hit the download zip and got all of the Python dependencies. And so then that is already on the robot, and even if we don't have a browser on there, the robot is going to go ahead and robot regardless.
Okay.
If you just like open the web page, then you have a portal to the machine running inside the robot. If it's not there, like I can close the browser, and like when I push this button, like it moves the tool head, like it will still do that regardless of the fact if I have the browser open or not. Or if you start up a program, well, again, you don't have to have a browser for any of this stuff. If you like started a drink robot and you had buttons on the wall or whatever, like
you could tell it just make gin and tonic.
yeah.
So.
I mean, and again, that's kind of like why I chose to do the JSON lines kind of format. So all of the kind of like native instructions and or because like fundamentally like everything that you're doing here like is some kind of like RPC, like a remote procedural call. It's like I have some object, I want you to take
Gotcha.
this data and act upon this. Fundamentally, again, like with the boxes and lines, like this is the actor model of programming. So kind of like the only way to interact with any of these guys is to like pass them a message, right? This is like the ultimate form of object-oriented programming, right? Like,
Sure.
And so fundamentally, because everything, I guess, are we okay on like this thing runs Python? We've got a browser, like how this is kind of constructed. Okay, so we have our programs here, and like we have a drink robot, but like we have a scale somewhere that is not on here. We just have some object. I don't think this is actually the robot
Let
bartender.
me try this one more time, how the pieces break down. There's some Python libraries on the cloud. There's WASM in your browser. The WASM in the browser gets its libraries from the Python in the cloud. It assembles those and sends that up to the Python in the.
Let me
robot.
stop you there.
No.
Okay.
No.
Anytime that I have WASM is replacing the Python that is running on the robot. So like the web page has no Python on it. You can make it have some Python on it if you want to build this robot inside of your browser.
Okay.
In which case, like, I can say that it is still connected to the robot over a web socket. But in this case, because we're running PyScript, I'm just basically going to the JavaScript side and say, yeah, that WebSocket, how about you just have a Python function instead? And because also duck typed this, that, like Python and JavaScript just like don't care about a lot of things, and as long as they have the same shape, you can go ahead and just like transfer one to the other. So effectively, instead of WebSocket, it's a Python function. JavaScript's like, here's some stuff WebSocket. It actually just ends up in Python. Wasm. Just like it would be over the WebSocket to the robot itself. Does that make sense? How they're like, they're not at the same time. It's a either or.
Okay. A bubble diagram would help, but I've
Also,
kind of got
Ed,
the picture.
I would suggest instead of saying files came from the cloud, you just say files came from somewhere. 'Cause
Well, it's important to me that it is specifically the cloud, because I don't like the cloud and I avoid it. And if I see something that has, if I see the word cloud, I'll close the page.
that's exactly my point.
And so if you can have the stuff locally, like you can have the stuff in a folder.
Yeah, you can.
Yes,
That's my point.
I understand that now. If you can have the stuff locally, but some, because of their business model, some companies put the stuff on a cloud and it's obfuscated or protected in
That's
such a
not
way
this.
that
Yeah.
you must use their service, and then they either follow you around when you don't want to be followed around, or they charge you money.
That's not this.
It's a business model,
Or they go away.
and that's not this.
Yeah.
You could just do a
What?
git check out of this. and
Or they go
run it
away.
locally.
Let's stop talking
Or you
about
close
other
their tab.
things. Get back to
Close
this.
their tab.
Yeah. No, I mean like 10 years from now.
Oh, yeah, they go away, and so does your
Yeah.
thing that you've made.
Yeah.
Cloud
No,
files
that's not my plan.
and your Bitcoin.
There are obvious benefits of having things run in the cloud sometimes, though. But anyways, I digress. So we have a drink robot here, but we have stuff like a scale that isn't necessarily here. So what we have here is like an element, and you can see that this is yellow here, which means that like we go up a level, and so then let's go ahead and kind of go up a level. You can see here that like we have what I'm calling clusters, and so in this cluster here, and I believe that we were here a moment ago.
I'd find a different word.
What's up?
That sounds like it has a Greek root. I'd find a different word.
Then cluster.
Yeah.
Let's make a suggestion.
What? Yeah. I'm not trying to
don't
solve.
understand something.
I'm not trying to solve.
So anyways, like this is the robot itself, and it's running Gerbil, but like the encoders on this one don't actually, the actual like chips themselves don't live on the same board as the robot. So we are sending this information. In this case, all of this stuff is wired up over CAN bus.
Okay.
Which is basically just another like serialized protocol to where you can send data over a wire. CAN bus is kind of neat in the way that like everything is kind of peer to peer. So there is no like hub and spoke model. Any client or member of the bus can talk to any other member of the bus, and suited to running hobby servos, right? Like one of the difficult things with hardware is, you actually need hardware that will accomplish the kind of electrical tasks that you have for, reading a Wheatstone bridge for a load cell, or, having 5-volt outputs and, the proper headers to run a servo, or some MOSFETs to run some colored lights at high power. So again, this is a way to, construct your larger object. To answer Bart's question earlier, it's like, I want to have 2 robot arms. You can have 2 robot arms here, and then create some sort of a connection between the 2 of them that can, start or initialize some kind of task somewhere else. And so, this is populated here by, you can send them up by, like sending them up. so that now these elements are exposed in the layer above. So I guess to get to the, like kind of what is all of this about, fundamentally we have constructed all of this stuff so that you can get to something like this little like bit of Python here, and we have a whole bunch of different objects here, scales, robots, servos, lights, this, that, and we have an API or whatever you wish to call this, just like where all these objects exist and have an API, and or all of the kind of ways to connect to all of these are all just like intrinsic to the way that you have constructed this out here, like as a config, and then you can just like have a few lines of code, Python code, and just like run your complex operation. Right, like gripper, it's nice to like call things gripper instead of just like what would you use to, what would be the G code to control a PWM?
M64.
All right, yeah. So like, fundamentally, like, what does this mean? Like, just Python, you can live up in, some high level abstraction and manipulate a bunch of these things without actually having to worry about, like, when I say to close the gripper, like, what is the actual PWM value that is, we need a 50 hertz, wave at, X number of milliseconds timing. Like, we don't have to think about that when we're up at this high level. And we can also, talk to and wait from objects that aren't even on the robot itself. Whether this is even just like, awaiting for a recipe from some web server for a specific cocktail or any of these kind of things. Fundamentally, we can get here and just with a few line of code, you can do some, really what I think is quite interesting things. I think I've been talking for about an hour, so I will kind of close it up. And
What connects CAN bus to the gerbil?
What connects CAN bus to gerbil? And fundamentally, you can see that there is no input here. So
I thought on your drink robot you had a bunch of things connected to gerbil, and you said it was CAN bus.
well, I mean, again, like, don't conflate gerbil and robot as the same thing, right? Like, gerbil like is the motion controller element that is down inside of the robot that makes the arm actually like move, but nothing up here is move the arm.
Oh, those yellow lines. Is that CAN bus?
Yes.
And that thing in the middle, gerbil?
This thing?
Yeah.
This is the robot. This is this is this. Let's close this one. Right? All of this code is inside of this block.
All right.
Like, if I viewed parent canvas, right? Like, we're just going to end up right here.
So somehow CAN bus is involved in sending signals in and out of here?
What uses CAN bus on this thing?
Well, I mean, there's no auxiliary boards connected to this thing as it's sitting on the table right now.
There's no CAN bus.
I mean, there's a CAN bus transceiver, but like, no CAN bus is making anything on there happen right now.
So what's on your screen right now?
What is on my screen right now is a higher level abstraction of the drink maker robot.
Gotcha.
And
Not what's on the table in front of you.
not what is on the table in front of me.
Okay.
So, like, in that, the other day, for those of you who came to the launch event, and thank you to everyone who came, we had a drink maker robot, and on there were a whole bunch of different circuit boards. Each one of these little blocks here is another separate circuit board. And so then when you drop them all onto this canvas and you wire them up, then the API between what this thing called gripper off and this thing that also happens to be called gripper off is automatically taken care of by how the parameter was constructed on the Python side to begin with. Like, every one of these objects knows how to serialize its own data, and thus when this is wired up, the other one knows how to unpack. They all know how to pack and unpack themselves. And so as long as the types are the same, and again, you can see that like when I'm dragging this around, there are only a certain bulbs that light up that this can be connected to. So like this particular one here, is a Boolean. And so it knows how to pack a Boolean. And then any of these other ones here that's also a Boolean will know how to unpack it. So any of these like higher level ones, you just need to match up. I mean, fundamentally, this is like a typing game, or we're just playing this similar thing that is at the crux of like all internet communications and high level APIs. And then a bunch of these, like this, let's see, set gripper, right? Like this one here should be, it is a Boolean. But if we open this guy up, what happened? I believe it was called gripper state, right? We're just gonna like go into this function and we're going to be getting a Boolean because we created this object and we sent it up to the canvas before. We've wired it up. It is of type Boolean. When this guy gets a message, it's also going to send a message. It's going to send it to this function, which is going to output a 0 or 1 and tell this duty element, like we originally started with the pen, to open or close to whatever these values that we set for open and close are. Does that make sense?
Yes.
Yeah. Any other questions?
So what was your launch event for?
For the robot arm. Thank you. I have a crowd supply campaign. So if anybody would like to have one or share on their social medias or whatever some links, that would make me very happy.
Where are the links?
I'm sorry?
Where are the links?
I will give them to you, but it's crowdsupply.evezer.com.
Oh, okay.
And any other questions?
Oh, thank you.
Thank you.